Now we're on the AP Chemistry Chapter 7 Notes, page 2, and we're going to be talking about orbitals today. And to understand orbitals, we're going to tell a little story. So we're going to a baseball/softball game where our class is playing another class. And because we are competitive, we really want to win this game. But also because we're low budget, we had to rent a stadium that is a little different than most stadiums, where in the stands there's actually a wall in front of the fans. So you can't really see the game, but what you can see is every 10 seconds this window in front of you opens and you could see the game for 1 second, every 10 seconds. It's just the way it is. So what we're going to do is we're going to watch the shortstop first. And when we look at the shortstop, every 10 seconds we see the shortstop is here, 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 catching a ball there, there, and there. Then we turn our attention to the pitcher. The pitcher is here, here, there, talking to the catcher, there, there. Then we look in the dugout, and we're watching in the dugout the coach is pacing back and forth. Every 10 seconds we see the coach going back and forth in the dugout. And lastly, we watch the first baseman. And the first baseman is here, 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 catching a foul ball, there, and there. So the point is this. If you're watching this game, you really don't know where any of the players are officially, but you probably would guess that the shortstop is in this region over here, that the pitcher is in this region over here, that in the dugout, the coach is going to be somewhere over here, and the first baseman is somewhere in that zone over there. So these are probably where the players are, and you're not guaranteed that they're there, but they're probably there. And if they go out of that area, they're going to go back to that area most of the time. And if the shortstop stands over here, the shortstop does not become the pitcher. The shortstop is still the shortstop, but the shortstop goes back to where the shortstop belongs. So just like baseball players have zones where you would probably find them, so electrons have zones where you're probably going to find them. And those zones, if you paid attention to the story, are S, P, D, and F that remind you of the shortstop, the pitcher, the dugout, and the first baseman. So these are 4 zones in which you will find electrons. So what do these zones look like? The zones look like this. If you had an S orbital, it's going to look like a sphere. All right? So a sphere, like a ball region around the nucleus. If you have a P orbital, it actually looks like this. It's like a peanut shape, and it has 2 lobes, one on this side, one on this side. That's one single orbital, and this is like where the nucleus would be right here. If you have a D orbital, it actually looks something like this. This is a single D orbital. It has 4 lobes on it. And this is, some of the Ds look like that. Most of them, one D orbital actually looks like this. So it has this middle zone right here where you could see as well. So they're different shapes. These orbitals are located in energy levels. Okay, so just like in the baseball game, there's no little fence holding this player here. If you look out on a baseball field, there's no fence holding the players where they belong. They just go there because that's where they belong. So is the same thing with orbitals. There's no little membrane holding an electron in this region or any kind of container holding it in this region. It just stays in that region because that's the orbital in which it is. So different energy levels have different orbitals. So level 1 only has S, level 2 has SP, 3 has SPD, 4 has SPDF. Now every level after that will add a letter. So 5 has SPDF and G. But there's no real energy level that uses these past the Fs because the elements that we have don't have enough electrons to fill these other orbitals, G, H, I, etc. Okay, so they're kind of theoretical, but you just have to know that they could exist. Now, the number of orbitals in each level depends on, again, what orbitals are there. So S's come in sets of 1. They come in sets of 1. P's come in sets of 3. D's come in sets of 5s, and F's come in sets of 7. So every energy level that has an S orbital is only going to have one of these. It's just that level 1 would have a ball orbital in the analogy, let's say this size, which is about a golf ball size, and then level 2, let's say, is a tennis ball size, and then let's say level 3 is a softball size, etc. So it's going to get bigger and bigger with each level. So there's only one of these in any level. However, the P's come in sets of 3, so this is one of them. So one of them is going to be in the X direction, one of them is going to be in the Y direction, and then one of them is going to be coming out at you in the Z direction. So that's why P orbitals come in sets of 3. D orbitals come in sets of 5. So this is one of them. So this is one D orbital. Now the orientation of these is a little more tricky. So this one kind of goes like this, then another one goes like this, and then another one goes like this, and another one goes like that, and then the last one goes straight up and down like this, okay, which you could see better this way. So that's the 5th D orbital, happens to look like this, and the others look like the one I showed you before. The F's, I don't even have models for that. The book has some pictures. They come in sets of 7, and they're oriented differently. Now, these orbitals can be easily filled using the periodic table to order them. Okay, so that'll be on the next video. I'm going to go over the order, but I'm going to, right now, help you understand how the periodic table is divided to tell you where each of these is. So the S orbitals are being filled by the elements that are on the far left, the group 1 and group 2. So this is the S zone being filled. Okay, the P orbitals, which we saw up here, are going to be filled by the elements on the far right of the periodic table. And then you saw the D orbitals over here. They're going to be in the middle. And then lastly, the F's are being filled by the elements on the very bottom, which are called the inner transition metals. The D's are being filled by the transition metals. All you have to remember the order is that S starts with 1, P starts with 2, D starts with 3, and F starts with 4. So it goes 1, 2, 3, 4, S, P, D, F. If you can just understand that, 1, 2, 3, 4, S, P, D, F, then that'll really help you on the next page.